Okay, so the quick guide for the mentioned Deye products. First of all, one very important thing to keep in mind is that the PV input voltage is usually lower compared to other brands' products. So we aim for that 600, 700 volt of input voltage range. Please keep that in mind, because if you design a string that is longer and hence higher in voltage, then it will cause malfunction or even an error or a hardware error in the inverter. After that, we move on to the battery input, because one of the very big advantages of the Deye inverter is the battery compatibility and the price of the batteries, of course. So basically, these are pictures from the user manual, and you need to remove the bottom cover of the inverter to see that part. This is where you make all the connections, and this is what you need to open if you are an installer. The top part of the inverter can also be removed, but it's only for the service centers of their products. So if you are an installer, you do not need to remove that, and you are not allowed to remove that without losing the warranty. So you only need to use the bottom part. Here on the left, you can find the positive and negative terminals for the battery connection. So this is what you have to use. It's the same if you use lithium batteries or acid batteries, that this is where you have to connect the batteries. From the AC side, you have three connection points. You have the grid, you have the load, and you have the generator. Basically, you have to use the grid most of the time, because here you can connect the power grid as a supply, and you can also inject back into the grid on that port. This is used, I believe, in like 80 or 90% of the installation. There is one little mistake in the user manual, because you can see three phases connected here and the neutral line, but the P is also here on the right side. You can show, or you can see from the circuit breaker on the right side, an additional rail. There you have to connect the PE. That's very important, because if you don't connect that, the inverter will not start up. And you have the load and the generator port, and we have another colleague here who will present after me, and he will introduce you the use cases of these two ports. Here also there is a highlighted area which shows you the connection of the CT wires. It's very important that you go from white to black, on all of the three CTs, and also that you leave empty the first two pins of these communication terminals, because it's for a battery thermostat. Basically, you get a device which you can measure the temperature of the batteries. If you are, for example, using a lead-acid battery, you put it in the middle of the battery, because that part will be heated the most, and then you connect it to the first two pins here. So if the inverter gets the data that the batteries are very high in temperature, it will shut down the battery port. So about the communication port, you can see that we are still in this part, and the bottom part where we open the inverter, and there is 6 connection terminals. And BMS is the one where you want to connect the PCS output of a battery. So it's very important that on their batteries, there is an import, there is an output, and there is a PCS port. In and out is used for parallel and series connection on the batteries, and only the PCS port is used to connect with the inverter. So you connect the battery PCS board or the port or the control box PCS port here on the inverter to the BMS port. Other than that, you can see the meter port. That one you have to use if you choose to install the system with a smart meter instead of the CTs. You can use Eastron or you can use Chint. In both cases, you have to connect there. And there is a very important appendix at the end of the user manual, which describes how this port is pinned. This is really important, because the high voltage Deye and the low voltage Deye has some differences in the pin distribution. So it will not work the same way in both cases. So before every installation, please make sure to check that the B and A ports are in a good place. Otherwise, the meter is the same. You just have to switch up the connection ports. Other than that, very important thing that you can make the measurement with the CTs and with the smart meter. One of them you have to install if you want to use batteries and if you want to realize zero injection work mode. We have a video also uploaded with the commissioning of Deye. It's like an 8-minute video, so it's highly recommended to watch that, and you can learn many things from that. It's also time-stamped, so you can search for specific parts of the installations very easily. and it doesn't take up a lot of time, but it will help you a lot. When you are thinking about making parallel connections with Deye, it's a bit tricky, so please make sure to consult with us before you do that, or just are 100% sure that you read the recommended part in the user manual, because it's written there, but sometimes there is a misunderstanding. Basically, there are two very big differences between low voltage and high voltage series. First of all, every Deye needs a battery if you want to use parallel connection. That's a very important note. It's not always the case for other brands, but in Deye's case, it's always this way. So you need batteries for parallel connections. If you have low voltage series, you just install the batteries, you put them on one power rail, and from that power rail, you connect to all of the batteries. So you will have like one cluster of batteries connecting to all of the inverters. In the high voltage series, however, you will need the exact amount and the same type of batteries on each inverter. Don't do that connection, the inverters will not work in parallel mode. So once you have assembled everything and connected everything to the inverter, then you go to the settings. This is a screenshot from the screen of the inverter. First of all, you have to go into the basic settings. This is a very important one because you can unlock the inverter here basically, and if you don't unlock it, you will not be able to change any settings on the inverter on the screen. Other than that, I will go over all of the installation possibility or the setting possibilities. So first of all, you get into the first page of the basic settings, and here you have two very important and one mildly important part. Basically, you want to remove the check mark from the B, because if you don't do that, the inverter will continuously make a very annoying sound. Other than that, you have lockout all changes option here. You want to remove the check mark from that. If you don't remove the check, it's basically there. It automatically gets there after a period of time. If you don't remove that, you will not be able to change any settings on the inverter. You will be able to see them, but you will not be able to change them. If you remove that mark, then you save it with the bottom right icon. Then you will be asked a password. This is 7777. And if you want to do a factory reset because you feel like something is messed up and you want to start over, or something is not working as intended, and you want to see if you start over it's the same, then you have to use a factory reset. And for that, the password is 49. And these two numbers are very important to keep in mind. Other than that, battery setting, of course, if you are not using batteries, then please choose the no bat mode. If you are choosing, or if you are using Deye's own batteries or any compatible batteries, use lithium mode. And if you are using lead acid batteries, then you need to use BAT-V mode. Other than that, you can give the capacity of the batteries that you know from the data sheet of the battery. Also, the maximum ampere charge and discharge values you have to set. This is also limited by the inverter and also limited from the battery side. So which one is the smaller should be the value here. For example, if you are using Pro B batteries, then the nominal ampere of the, or nominal current of the Pro B battery is 50 amps. So if you're using 3 pieces of Pro B, you should set 150 here, both on charge and on discharge. So basically, in case of lithium batteries, it's almost every time quite the same value. On the second page, if you go one page down with the arrow on the right, then you will see 2 charge possibilities. Basically, if you want to charge the batteries with the generator, or if you want to charge the batteries from the grid. From the grid, I think you should be allowed to charge. I mean, you should allow that option, but you should reduce this percentage to around 5% to make sure if the battery drops down to 5%, it will start charging from the grid. So you can avoid many malfunctions with that option. On the third page, you will see 3 percentages in lithium mode. Lithium mode is set to 0 automatically. It's for the compatible batteries and Deye's own batteries as well, so you don't need to change that. If you, for some reason, it's not on 0, then please set it to 0, but I never encountered a situation where this was changed originally. Shutdown percentage, it's a percentage after, or an SOC state after which the batteries will not discharge any current, and low BAT state or low BAT SOC level is a level under which the battery will only discharge current if there is no grid connection. So for example, there is a blackout, then in that case, if the settings are like this on the presentation, you will be able to use 10% of the battery's reserves because it's reserved for blackout scenarios. Restart percentage is the amount until which the battery has to be recharged before it starts discharging again. Okay, next up, system work mode settings. This is a very important one. Please make sure that it's set on 0 export to CT most of the time. So it's a basic household installation, only grid disconnected. You have to use 0 export to CT. If you use 0 export to load on the grid port, there would be no consumers that get any power from the inverter. Other than that, you have here the solar cell option. Solar cell is basically the 0 inject settings. So if solar cell is marked, then the inverter will be able to feed back onto, or inject back into the grid. If the mark is removed, the inverter will not inject back anything into the grid. This is separate for 0 export to load, and this is separate for 0 export to CT. So make sure that you put the mark in the same row which mode you are using. Other than that, you can raise the 0 export power. That one is for the 0 inject reserve. So basically that amount of power will also always be taken from the grid. So when you turn off a consumer, it will have some time to regulate the inverter AC output. So it will not inject anything back into the grid. If you have big consumers on the side, then you can raise this power to like 40 or 80 watts, and you will see that it will not feed or not inject back anything into the grid. Otherwise, it can sometimes, when you switch off the consumers, like add a little bit back to the grid. I believe for most competitors, this is also around 20, 30, sometimes 50 watts, dependent on the brand. And also, you have energy pattern here, which you should usually set to load first, because load firstly will try to give energy to the loads instead of charging the battery. And you should use bat first if you have instable grid connection there and you always want to keep the batteries charged up. On the system work mode second page, there is a very important mark to make. This is the time of use mark. If you don't check the time of use, then the battery will not discharge any current until grid is connected. So you will not be able to use your batteries. There on the right side, there is also a percentage level. This would be the percentage level for that given time period until the batteries can discharge. So if you raise them, so this is basically the same as the battery low percentage on the first few settings that I showed you. But these ones can be set higher. They cannot be set lower, but can be set higher. So if you want a certain time period in which you don't want the battery to discharge, you can raise the percentages there. After that, the grid settings. Usually we use VD4105 grid code. This is the generals for Germany, for Austria, I believe as well. We used in Hungary. I'm not that familiar with all of the grid codes around Europe, but I think this can be used by most of the countries. And we have 50 Hertz connection. Also, you can rotate the phase order with the phase type settings. You don't need to physically change the phases. If you have a W03 error code, that means that the grid phase is wrong. It's also written on the screen of the inverter. Then you just need to switch the phase type. When you try to do that, it will raise a warning that you may cause a malfunction or a direct error in the inverter if you do that. But please stay calm and just do that, because even if you do it in the wrong direction, it will not harm the inverter. Other than that, a grid level you should usually set to 230. I don't know of any countries that have still 220. Maybe there are some, but this one you need to check for your own country. In the advanced function, there is a parallel setting which could be important, but as I mentioned, please make a short conversation with us before you want to install a parallel system with Deye, just to make sure everything is fine and you are well prepared for the installation. And there is an option for the meter. So if you want to use an external meter instead of the original CTs, you have to mark that setting, and you have to choose which kind of meter you are using, the Chint or the Eastron. If you don't change that and you have a meter connected, it will not measure anything at that point. When you install, you can find the password for the Wi-Fi dongle on the bottom part. You can also read that QR code with your phone when you are installing, so you need to add the logger into the plant on the Deye cloud. And this device will add the inverter itself. And in operation, like when you are using the Deye cloud, you have to create a plant when you're installing a new system. This is the only page that you have to fill out and save. Then you will have the plant up and running. And also you have to add the the user later on. So the user you need to create from the user's phone, or then they can create for themselves, like they have to go to their cloud and just register as an end user. And then when you created the site, you will be able to add it as a user. As I mentioned, we make several videos. So we try to do educational content and try to upload educational content on our YouTube channel. So if you are interested and you are new to a product, it's highly recommended that you check out these videos. We made several ones already for both Deye, Solux. We also made some for Huawei, and these can be a lot of help. Other than that, we have these uploaded on the web shop and on our webpage as well. And we have Tamás here, Tamás Trezi, who is like our external expert for the Deye products, and he will give you a bit deeper technical introduction and also mentioning some of the most common mistakes. So please give an applause for Tamás.
Hello and welcome to our English audience. So my name is Tamás. I came from kind of a user side of Deye. I lived with this three-phase inverters, and I know it very well as a production engineer previously and electrician. I had the insight, and I was willing to help people having bad installations. Due to government incentives, we have lots of three-phase Deye systems running in Hungary. And unfortunately, many installers did a lousy job installing these inverters. And they, in many cases, have not operated correctly or even failed to work at all. I came in contact with SolarKit, and through SolarKit, I help their partners when there is a problem with the installation, or I can even give lectures and so show you guys the installations in the first place so you won't make common mistakes. Okay, on the first page you can see the basic connection, the most common connections we do. This is a typical NPP connection where only the grid side is connected, AC coupling with the existing AC systems of the house. As Peter has already mentioned, the rotation order of the phases is kind of a non-issue. It's not really important. You can change it anytime in the inverter settings. No physical connection changes are necessary. The only important thing is that your phases match the CT phases they're attached to exactly. You follow the same order and you are good. A really important aspect of using a Deye inverter is the software and the cloud environment it provides. Deye Cloud and SolarMan are really good applications. It gives you a really good insight to what's happening with your inverter. So setting up your cloud account and your customers' cloud accounts is really important. Most of the time I start investigations with requiring access or being added as a user to the plant in question, which you can do in the app via the authorized functions. It's pretty much the same in SolarMan and Deye Cloud. And after that, I take a look, a long look at the data, analyzing a few days worth of production and inverter parameters. There are a couple of dozens of parameters you can follow under the inverter in Deye Cloud, and you can set up custom views. It's really, really a powerful tool to find faults and even change settings. It's also important to mention that whatever you can change settings on the inverter, you can also do it from Deye Cloud remotely. And there were quite a few problems which I managed to solve from remote without the need of actually having to go to the installation. It's not always the case, but sometimes it is, and it's an important starting point. Okay, let's go through the few common problems and the resolutions I found on the field. Often it starts with customers complaining first to you guys, the installers, and sometimes to the wholesaler directly. That their expected energy savings are not there, or in fact their energy bills are going up and the electricity meter is actually measuring more than before the installation. It's an unfortunate situation We don't ever wish for our customers not to be happy. And yeah, in some cases, there are not the wealthiest of customers. So let's see what's common problems I found. Achilles heel, if you will, of the Deye system are the CTs and their setup. What I already mentioned, that the CTs have to match the grid phases exactly, is pretty much the most basic mistake made. And you shouldn't head just blindly and follow the actual product brochure about the installation, because there were a series of CTs where the directions were reversed. So black and white may not be black and white, and the arrow may not point into the right direction. But this is something that you can check at the inverter immediately during the installation. You have to provide a stable load to the house and check your values. You have to read positive values and loading up the phases individually. Even you can do this on the inverter terminals with probes and the load. You should immediately see a positive value. So you load up L1, you read a positive value, increasing value in CT1, you are good. And then you go in turn, and that's the basic method. And it's especially important when you have to extend the CTs. You are using a Cat 6e, which is 20 meters away, the CTs, and you might miss the actual pairs of wires. But with this loading method, you can pretty much blindly find out the right pairs and the right direction of the CTs. One interesting issue was during these extensions with Cat 6e that the copper wire wasn't exposed properly. They assumed that the connecting terminals are self-cutting, which they are not. So you always have to make sure that the wires are properly stripped. I would also suggest using ferrules even on the factory connections, because the wires are really, really thin and they can be brittle when you insert them to the connection. So using a small but longer type of ferrule helps a lot to make a proper secure connection. And since the CTs are kind of the error signal of a highly complex inverter circuit, getting a wrong error signal makes the inverter go really crazy. I've seen inverters running, feeding in one phase and producing energy on the other phase and running for months in circles at a really high temperature. Which is also one of my key tools to detect these kind of problems, is checking the inverter temperature. And the inverter temperature is, and if the inverter temperature is high, even during the night, no solar production, no loads, I know that there is an inverter running in circles and producing power and consuming it at the same time. And if you're unlucky, it turns your electricity or utility meter in both ways and increases the consumption amounts considerably. One of the other problems, and is especially accentuated during the winter time, is that the batteries are cold, especially if the installation is outside or in a semi-protected area, and the battery temperature gets cold. The BMS limits the charging capability of the pack, and combined with the shorter periods of sunshine and much less sunshine to start with, the batteries get flat. So it's important to correctly set the battery thresholds and the operation mode of the inverter so it could consume as few energy as possible. One interesting aspect, I found it as setting battery first helps a little bit when the battery is already at threshold. It gives a few tenths of watts more to the battery instead of immediately consuming it on the load side. It's when the battery is at the low threshold. One other problem with the batteries, and charging is the factory limits. I think Peter showed a good picture before where you can see the charge and discharge limits set to 40 amps. I think that's the factory default. And the important thing is that the minimum charge and discharge are always the minimum of your set value and whatever the BMS tells you. So even though the BMS provides you with the hundreds of 100 amps discharge, if you have 40 set in the settings page, you will only have 40 amps as a discharge. So the inverter will only provide 2 kilowatts. That's a common issue I see in many installations, that they didn't change this default amperage of the battery. My pet peeve is advanced and asymmetry. This function is called asymmetry, but it's not really. I checked it up in the Modbus communication, and it's called active unbalanced load, which means that the inverter is continuously working to equalize the consumption to the meter side. So, for example, if you have a 3 kilowatt load and the battery is flat, again, we are talking about the winter conditions. So if you have 3 kilowatt load on the inverter or in your house, the Deye is working in such a way, if this option is on, that it presents this as 3 times 1 kilowatt load on each phase to the electricity grid. So it actively balances the load, which is a good thing, because you might have a household where there is too much load on one phase, and the Deye solves this for you automatically. However, as with any conversion, there is losses, and in winter operation, this could result in a battery being already at 20%, going further down during the night, because it takes some energy to run this conversation all the time. So it's important, if you have a just simple basic installation, that to leave this option off. Let me talk a few words about the common physical installations problems I've seen. This is something probably you never make, but yeah, these happened. So unsecure or non-connected, no connection. This was kind of one-off. Electrician mistook a particular junction box, assumed that some terminals were connected, but they were not. So the null was floating, and the inverter kind of shut off as soon as you applied any household loads to it. It was really interesting, because that state actually pulled the null towards the active phase. So the voltage towards other phases made the grid connections fail, because there was 90 volts between one phase and null, and there were 350 watts between null and the other phases. So really interesting problem, but one-off. SWAT phases, again, try to maintain a system where you keep L1, L2, L3, whatever order you prefer, but make sure you keep to those. There are some color codes in Hungary, but it varies from electrician to electrician. Interesting is to keep your system 1 to 3 and match the CTs to that. Loose connections on the AC cabling side, both in the actual inverter, it's always important. And whenever I go out for a repair, I always do routinely, I tighten the bolts on both sides of the terminal, because the Chinese manufacturers sometimes do not tighten these enough, and there were some loose connections, not on the user side, but on the inverter side. So as a routine, I go through them, and let's say 1 in 10, I find some connections which are not tight enough. Also, the pre-made junction boxes, AC and also DC junction boxes, always make sure that the connections are tight and secure. And the most important place where secure connection needs to be established is the battery side, because the amperage is much higher. There is a really funny picture in the booklet of the inverter when you're supposed to tighten it with a flathead screwdriver. That's totally unacceptable. you need a proper wrench and a 17th gauge socket and tighten those connections properly. You would be surprised how many electricians did not do this. And over the long term, it's a fire hazard. Just one important thing at the end, despite seeing these inverters running incorrectly set up for months, really consuming lots of energy and being really hot in many cases, I'm yet to see a definite failure of an inverter. So I think there is a good base. Another important aspect to educate the customers that this is a relatively complex inverter with 3 phases designed mainly for off-grid operations. So it does consume energy, even just running on your wall, while it provides, great value. It's also providing UPS capabilities. But yeah, it still consumes energy. There is about an 80-watt draw, constant draw of the inverter of the 3-phase models, just a fraction of even a winter's day's production. But yeah, it's best to let the customers know that this is there and what to expect. There is a list I already mentioned partially, how to prevent batteries going flat in the winter. As I said, battery first helps a little bit. Asymmetry off helps a bit more. And setting a time of use period where you actually charge the battery a bit higher. A typical setting of time of use is just setting a base value, let's say 20%. Battery can go down to 20% and charges up to 100 when there is enough sunshine. But adding a short slot during the day with 25% instead of 20 ensures that the battery is a bit, the BMS system is moving just a little bit. In that section, the battery will actually take advantage and get charged instead of the load supported, and it helps to keep the BMS calibrated correctly. There's also an option of charging the batteries from the grid, which is not the best, but you have to keep in mind that charging from the grid is just producing a small amount of loss due to conversions, but you don't lose the whole energy that you are charging. And I would suggest to set a time slot somewhere early in the morning when you set the battery to charge from that base level of 20% to up to, let's say, 25%. That also heats up a battery just a little bit. You can set the charge amps and wattage in the battery settings. What's important to keep in mind that when Deye charges the battery, it doesn't support loads. So it's best to charge it from the grid if there is a need to, when there is no activity. That's why I suggest a time slot in the morning. So far, I've already talked about the basic installations and a single grid side connection. How you move further from this. It's having a UPS functionality is a really desirable trait of the Deye inverter. And since it's designed from the ground up as an off-grid inverter, I think this is what it does best. In this case, you are connecting to the load port. The actual installation is really important to keep the safety of your electricity systems. It's also dependent on the regulations of your distribution network operator, whether this is actually allowed or not. In Hungary, it is, with some DNOs. And yeah, we hope it will be allowed in general. So in this operation, they will disconnect from the grid when there is a brownout or blackout or over voltage conditions, which is becoming a more frequent event. What you need to know is that the Deye is always charging the battery even when the grid is down. So that's already a plus. But in this connection, you can also support house loads during a blackout or an overvoltage conditions where your grid tie inverter would otherwise just disconnect and you would lose the whole generation. Okay, as I said, the proper connection of the neutral and RCD devices are critically important, because basically in this case you are creating your own electrical network, which is under voltage pretty much at all times. One more important thing which Deye doesn't mention, if you use the load connection, it's best practice to add a switch, a service switch, where you can switch the load side back to the grid side, whether your inverter is broken or fails one way or another. It's best to have this kind of service switch installed so you can have electricity from the grid as normal. It's specific to Hungary, really, but as a generic knowledge is good to know about. We have net metering contracts which expired after 10 years, so we have a potential customer base who are having a grid tie installation which doesn't worth a lot anymore. And you can extend these installations with the retrofit of a Deye inverter and batteries, basically creating an AC coupled battery. Whether you want to just swap the inverter, which the customer already has, to a new hybrid inverter, or actually place another inverter as an AC coupled energy storage system, depends on whether the customer has enough space, or, for example, if you have a Huawei inverter on the roof of the customer with lots of optimizers, you cannot simply swap it for a day because it won't start, and you have to pay people to go up to the roof. So instead of doing that, if the customer has enough space, you only need a small amount of wall space and space for the batteries underneath and an AC connection, then you can install Deye in parallel and program it as an AC coupled energy storage device. With varying time energy prices, it could be a standalone solutions in the coming years to install these AC coupled storage devices even without solar. I think there's in the UK it's already a huge market, and people just starting to actually forget solar. They just buy storage because there are times of the day when you can buy electricity really cheap and you can run on it or even sell it back to the grid when it's more expensive. And I think it will become a much widely used business model, even here in mainland Europe. Just a quick mention about connecting all three ports of the Deye. This is when you connect a grid tie inverter system to the generator port. It's pretty much the same that the AC couple I explained before, with the added benefit that even in a blackout or overvoltage situation, your old grid tie inverter will keep running on the generator port and on the grid provided by the Deye. So you can run a used to be on-grid system completely off-grid underneath the Deye and have your storage. And yeah, it's could be a really good solution for some customers. And one other added benefit is that with the grid tie inverter on the generator port, your actual power capacity increases with that. So if you have a 10 kW Deye with a 10 kW Huawei on the gen port during the day, and if it's sunny, you can supply almost 20 kilowatts of power to your AC circuits. So it's a really good opportunity. I think it has its place. Okay, yeah, just a question regarding this. No, it's not possible. Deye does not run off-grid without battery storage. It's pretty much a requisite to have a battery to run off-grid, and yeah, it won't even sync with the diesel generator in this case. But apparently Huawei has the solution, has you covered. So if you are looking for such a solution, you have to look for Huawei and buy from SolarKit. Thank you very much.